Hey everybody, welcome. So today we're going to talk about HMIs. So I introduced this briefly last meeting, and I was thinking like, oh yeah, this is pretty straightforward. So I'll just throw a field example at you guys and assume you picked it up. And then I got to thinking about it, and I was like, most of the stuff that winds up confusing me in school isn't necessarily super complicated. It's usually more simple, and it's usually the things that the professors think you'll just intuitively figure out. And so they don't bother explaining it or talking about it very much. And then I'm like, I have no idea what you're talking about. And it's usually a fairly simple thing. So I want to just kind of start from the beginning, talking about touchscreens and how we're going to program it. So first of all, is this a good pen? Nope, that's a bad pen. First of all, I'm going to throw that away and get a new one. So up till now, we've been working on a PLC, and it's got inputs and outputs that are like physical buttons, right? So if you remember, that's our symbol for a push button, a normally open push button. And then we got like your output lights that are little diodes. And so all the programming that we've done in ladder logic, if this is your ladder logic rungs, has been with contacts and coils that are associated with actual physical hardware. So this open contact would be this push button, and this coil would be wired to this diode here, right? So that's all well and good, and I think it's pretty intuitive to understand how that's firing together, right? But now we're going to go into the world of touchscreens. Well, okay, before I go there, one more thing. Now this contact in the PLC is a bit, right? And so that's represented in the PLC. Oh God. That's represented in the PLC as a memory bit that's blocked off by the light so you can't see it. And that's going to be a 1 or a 0, right? And same thing for this output. That's also just a bit in memory that's a 1 or a 0. Okay, so moving on to talking about touchscreens. Now, our PLC is connected to an HMI. It stands for Human Machine Interface. And this is a programmable touchscreen. You saw this last meeting where you can program buttons and lights and whistles and displays and show your instant messengers from work to the class. And so yeah, you can program all this stuff on the screen. And then this HMI, as shown by this dotted line, is talking over the network to the PLC. Okay, and so this is for us, this is an Ethernet connection. It's I forget what the protocol is. I think it's Ether IP, but I'm not 100% sure on that. But the point is, this is a two-way data highway, right? And at least for our purposes, we can pass as much data as we want here. It's not limited by the physical number of wires going between these two components, this PLC and this HMI, right? Whereas before, all this was kind of limited by the amount of hardware we had available, right? So we had 4 buttons, we had 4 lights, and that was kind of it. We have quick connects on the side of the panel for sensors and stuff, but you're really playing with, you're trying to write a program to control this motor, and you got 4 buttons to play with, right? So the beauty of having a touchscreen is you don't have to have a bunch of hardware to get more user interface points to this controller, right? So now you can add keyboard and buttons and switches and then lights, and I think this HMI does audible sounds as well. So there's all this stuff that you can now just program, right? And so the important thing to understand is that all that stuff that you program is basically just working off the same type of memory bits as we've been using before with these buttons and lights and switches, right? The PLC in its memory, it just has a block of memory for a bit, right? And all it knows is this is a 1 or a 0 and it's controlled by something. The status of this memory is controlled by an external stimulus, right? And I'm just full of these blocks and I don't know what's writing in or out of these or what's writing in or reading these off. I just know what the status of them, the status of those bits is, right? And so for the HMI to PLC communication, all you have to do is define tags. Okay, and what that looks like is, generally speaking, we're going to start defining these in the PLC and then migrate them into the HMI. You can do that either direction. You could define them in the HMI first and then go define them in the PLC. But you want to make sure, generally speaking, it's usually easier to start on the PLC side because you have a specific use for it, right? Or a specific function that you're using it for. And so it makes more sense to define it there and then go over and define it in the HMI. In these tags, basically most of the information you're going to need is the type, okay? And that's memory type. And so that could be a bit, it could be an integer, it could be a float, or any of the other data types we have, right? And then you need a nickname. Okay. And this nickname is really, it's really the key piece. It's got to be the same on both sides, right? Because when you assign a nickname to this tag, you're actually really, you're creating an addressing system between the PLC and the HMI. So if I name my bit Bob and in the PLC, I say set Bob to 1, then over here in the HMI can go, okay, I want to know what's up with Bob, right? Bob, is Bob a 1 or a 0, right? And we go and we look in the PLC at the bit for Bob, and it's going to be a 1 or a 0, okay? And that's going to get transmitted back to the HMI, and it's going to say Bob is equal to 1, right? And then on the HMI, you can do stuff based on the state of Bob. So on here, we might have a little display box that's monitoring Bob, and if Bob is a 1, we're good, right? And if Bob is a 0, then we're sad face, right? Or something like that. You can program this to be whatever you want, right? You could display a number, you could display anything. And so that's really all we're doing is opening up a new way to access memory in the PLC. And we're also opening up another input point to the PLC that allows us to really start putting in more detailed information other than just a 1 or a 0. Because previously we've been using a push button, right? A push button, it's either on or it's off, right? But now on here, we can make things where we can type in a number, right? And that can be anywhere from 1 to 1,000,000 or whatever we define it to be. And so it makes it much easier if we want to. So if we want to say, I want my VFD to be spinning at 50, it's much easier to go in and type in the number 50 on your HMI and have that right into the PLC than it is to go hit the push button 50 times to scale up to 50, right? So that's the gist of why we're using why you would want to use an HMI and how you kind of implement it from a programming perspective. Okay, I think that's all I want to say on the intro side. So now we'll move over to the actual software and we'll start looking at these things. Wrong one. Rescale this one time. Okay. I'll move the camera too, so you can actually see the panel and stuff. Dogs are losing it. Oh, we got to do a pup date at the end of today. Don't let me forget. For anybody that wants to see it. Okay. So down here in the bottom left of my screen, you can see the actual HMI screen that I've programmed. And it has three things. It has an on-off switch. It has a readout of the actual motor speed that it's measuring. And then it has this VFD percentage box that you can touch on, and it pulls up a typing pad where you can type in whatever number you want, right? And it tells you down here in the bottom, man, you really can't see that. Let's see if I shade it. No, you're not going to be able to see it. I'll show you in the actual configuration software. So here on my screen now, you can see this is where I programmed that setup. And for this VFD speed box, when you open it up, there's a setting in here for range. And so you can set this to be basically any number you want, up to huge numbers. And that's actually determined by the data type for the associated tag. So if you just if you assign like a float or an I2, that upper range can be much bigger than that is if you assign it just a regular integer. Okay. So whatever you type in on this min-max setting determines the min-max number you can type in here. So just as an example, I'm going to try to type a number that's bigger than 100 in there, and it tells me entry too high. I'm not going to let you do that. Okay. So, but if I type in anything from 0 to 100, it'll accept that as an input and it'll write it in. Now, in the code here, you can see in this configuration block, there's the data entry tag and data display tag. Okay. And so for us, those are going to be one and the same. But what this is telling you is that you can have in this the data entry tag, you enter a tag that it writes data into, right? And then if you want, you can use a display tag and have a different tag that's the actual number that's displayed on the screen. It's complicated and confusing, and you don't want to do it that way. Okay, so I want to go back to my PLC code and show you in here somewhere. Okay, right here on line number 5, you'll see I have a copy block, okay? And what it's doing is it's looking, let me open my data address picker. So if you look at DF10, I've nicknamed this. And so all you have to do is when you're in your data picker, picking a point in memory that you want to assign to something in your code, all you have to do is change the edit mode and then edit this nickname. And then now this is now this can be used as a tag on the HMI. Okay. So if I'm writing this code, I go and I write this line, this copy block, and I say, okay, DF10 is going to be my motor speed input from the HMI to the PLC. And I want to read whatever the user input there, and I want to write that into my analog output. Okay. And so if you look at the way this copy block is set up, the source data is DF10 and the destination data is DF5. Now, if you remember back, DF5 is our analog out to the VFD. So all this is doing is it's taking a number from the HMI that's 0 to 100, and it's writing it into that output address, and that output address is scaled from 0 to 100. So there's no math or anything we need to do in here. But if you did, right, if you know, if your user input was 0 to 6,000 and your analog out was scaled from 0 to 100, then you just put, instead of putting a copy block, you just put a math block in here that does that proportion, it multiplies by that ratio. So when it's doing that copy from DF10 to DF5, it's scaling it appropriately. Okay, so that's what it looks like on the PLC side. And then all you got to do over here, when you're opening a block, is you can open up the tag name database. Okay, and I'm just gonna I'm actually just gonna delete this and then recreate it to show you. Oh shoot, it's not gonna let me delete it. Okay, so if you didn't already have this tag in here, right, you would go into add tag, and I've named the PLC in this program. You have to define the communications between the PLC and the HMI in this HMI software. So I've already done that, and the PLC is just dev001. Dev is device. Okay. So if I wanted to recreate this, I would make this M1 speed, and it's case sensitive, and you need to get the exact same nickname from the PLC for your tag name, or it's not going to work right. And then in your you can select the data type for your memory, right? For us, we know it's a floating point 32. Memory type, all we have available is DF, and then you can actually go, or you have to go and you type DF10, because that's your address in the PLC. Okay, cool, add. Okay, it doesn't like that because that tag already exists, but that's how you would go through and add it. Okay, so now that now this is fully defined, I have my tag assigned, and so now this is configured to where you type it in, it takes that data and it dumps it into the PLC, and then the PLC does whatever code you wrote. Okay, so now you have data going from the HMI to the PLC. Now the rest of this configuration is just basically settings for how you want it to look. So I'm gonna define a new thing in this program. I'll move this stuff around, get it out of the way. So I got room to work. And you can see I'm just clicking, dragging these all of these objects. So I want to define an indicator button. So I'm going to go over here to indicator button. There's a huge list of buttons I can use. And I'm going to just grab this default on off button, and I'm going to drag it over and drop it. Okay. And I'm just going to, actually, you know what? I'm going to do what I told you to do before and start on the PLC side. So I have all this code. I'm going to go down to the end, and I'm going to make this really simple. I'm going to make this normally open. I'm just going to call it C, or no, I'm going to pull up my address picker. So if you guys remember, I talked briefly about this last week, where there's this C bit type, and that stands for coil, and it's an internal coil on the PLC. So this is not associated with actual physical I/O like the X and Y types are. C is just, it just stands for internal virtual coil. And so this is what you want to use, generally speaking, for bits between the HMI and the PLC, because you don't have to worry about there being conflict between physical I/O and the virtual I/O from the HMI. So I'm going to just name this, I'm going to use all caps, and I'm just going to name it indicator. Okay. There'll be like some companies will have conventions for how you name tags, or if you're working on like a specific project, you might have a P&ID or something that you would want to use associated tag names for. If not, just make them up, keep a list, right? Start a file of all your tags, so you know what they are. Okay, so now I have that assigned to a normally open. And then I'm going to have an actual physical output, and I'm going to use Y. I'm going to use Y001 because that's my red light. Okay, so I've written my PLC code, so I'm going to write that into the PLC right now before I forget. Then I'm going to go to the HMI side, and I'm going to drag that button in. I'm going to go to the tags database, and I'm going to add the tag indicator. That's how I spelled that, right? Yeah. Yeah, you always got to make sure your spelling is correct. And then I remember it's a discrete, and it's a C memory type. And I'm going to make that 2. Now I want you to just take note that when you're adding this tag, you're adding it for that button, and it knows for that button that it's a discrete value. It's not a what am I looking for here? You couldn't assign this as a floating point value, right? It's just a 1 or a 0. It's a bit. It's on or off. Cool. Okay, so now I've added this. I'm going to use this as my tag for the button. All right. Cool. So now I have a button. Pretty cool. Super cool. So I'm going to save this, and then I'm going to write this file into the touchscreen. And it's gonna think about what it wants to do with its life for a minute. Okay. Let us do it. Wow. So pretty. Okay, so now I have a new screen with this button right here. And I think when I hit this button's going to turn green, and that light's going to turn on if I did this correctly. So let's see. Sure works. Happy day. Okay, so you can see the nice thing about this indicator button is when I push this button, it changes colors, right? So I know I pressed it correctly. And then you can see in the ladder logic, this normally open contact is changing states. And then the output is being energized when I press that. Pretty neat. I mean, it's not super exciting, but now this means I don't need a physical button to toggle that light, right? And I could also make a virtual light on this screen that's toggled by this button, right? And then monitor those memory bits in the PLC and do other stuff based on the status of this button, and then also indicate on this screen that the stuff that I programmed in the PLC is happening by another indicator light. Okay. So the last thing I want to do with this is this looks pretty cool when it's on, right? It's green, it's nice, but the text is kind of small. So I'm going to go ahead and I'm going to change that text to like 30. 30. Oh, because I'm doing it. Yeah, I was doing that in the off. So 30. There we go. Much better. I'm gonna go ahead and make that even bigger though. Let's try 50. Yeah, I like that. Okay. And then I'm gonna make the off also be 50, and then I'm gonna make the color on the off red. And then I'm just gonna one real quick, check this out. I'm gonna go into simulate off. Okay, cool, off. So you can actually check how visually how your screen looks by just toggling that simulate button, right? And so you, depending on where you leave those simulated states, your HMI program might look different, right? Um, so I think I've fairly well demonstrated like the basic blocks and items that you'll have on these screens. Now, some of them, again, this is just a simple on-off, but as I showed you before, for your VFD, um, you can have this block type by default allows the user to click on it and enter data, right? It just automatically, this block that I selected comes with a user entry keyboard. So before we get any farther with this, if you don't, I assigned a homework to install this HMI software locally. If you don't have it, I'm working with the department to get it installed on the VMs. It's in progress. It should be done by next week. But if you don't have access to it right now, don't worry. That's what kind of why I'm going through this in such detail. So you should be able to play around with that soon. Okay, so the last and probably more complicated aspect of HMIs is that you can have multiple screens. And so when you're setting this up, like you might have, this would be our screen for motor control, right? And then we might have another screen to control another motor, or where we input a bunch of user set points into the process that has a bunch of these type pads on it, right? And you have to define the navigation in the software. So I probably should have actually worked on this before, because I don't know how to add another screen. There we go. It's under new screen. Okay. So I'm gonna name this new screen. Help me out, guys. What should we make another screen for? Just throw out ideas.
Light control.
Light control. All right, I like that. Okay. Oh, you also might not be a huge fan of my color choice. For the color scheme on this screen, I know it's a little funky. I spent a lot of time trying to figure out something that would be fairly visible on the camera, because if it's a white background, it washes everything out and you can't see anything. So darker colors and vibrant greens are generally pretty decent for that. So that's what we're going to stick with. And we'll just make a description called test lights screen. Boom. Okay. Oh, why is that so ugly? Oh, I know why it's so ugly. Ha. Forgot about that. Okay, so I forgot on this screen, instead of changing the background color, I just added a big black box behind it to wash it out. So you can see here, the benefit to not doing that is these grid lines actually show you the touchscreen nodes. So every intersection point on there is actually a point that it's sensitive to touch. And so that can be important if you're trying to shrink a bunch of small stuff on there. Just seeing where like any overlap might be between buttons and stuff. So, okay, so we have these two screens. I'm actually going to grab this button and paste it onto our new screen because this is our light control screen. And I'm going to rename this screen to be motor. Oh, never mind. The motor control. Okay, so I got my one button on the light control. Now, what I need is a navigation button, and where is it? I think they have a default button on here. Yeah. So if you go to under control, there's a screen change push button, and there's also a screen selector button. And so the difference between these is the screen change push button. If I stick this on here, and I can configure it. There we go. Okay. So if you guys see here down on the bottom, it's got this go to, and the option is other screen. And so you can select what screen this navigates to when you hit the button. Okay. The other option in here is screen selector. And so the way that works is it'll just display a list of screens, or a list of buttons, and you hit any one of those buttons and it takes you to the associated screen number or screen name, right? So it's kind of preference. If you do have like more than maybe 5 screens in your program, you probably want to use the screen change push button. Okay, but as you can imagine, you can start to get like what you would call in CS like a really wild data map, right? Where it's like spaghetti. Like screen 1 can go to screen 5 and 6, but then screen 6 can go to screen 2 and 3, but not 1, and so you get this like wild navigation tree. So when you're doing it with the screen change push button method, make sure that you have like a good map. Like literally, you can just draw it on paper of your screen navigation, because you want to make sure that it's logical and that users are able to follow it. So I'm just going to use the screen change button. I'm going to change it to motors, and I'm going to make it green so we can see it. And I'm going to make it big, and I'm going to make the text big. And then over here, I'm going to do another navigation button called lights. And I'm going to make it green and big. And I'm going to make it navigate to light control. I'm going to make that big. Okay. I'm going to write that in. Oh, yeah. That wants you to save it before it writes it. Imagine that. Ugh. Okay. Just thinking about it. It wants to do it. All right. Who thinks this is going to work? Oh, your confidence is overwhelming. She works. Cool. So now I have 2 screens that I can jump between. So the nice thing is this HMI is actually huge compared to what you usually get. Like I've worked on what they call air handlers. It's just a giant air conditioning basically. And you get it, sometimes you get a screen that's about this big. And so you're like, you know, if you got big gorilla hands like me, you're like trying to trying to peck at these tiny little buttons that are like the size of your fingertip, and you're like hitting the wrong button and stuff, and it's a total nightmare. So the nice thing about this screen is it's big enough to where I can actually make these buttons huge, so that even through a GoPro over the internet, you can still read what most of this says, right? But on those systems where you get tiny little screens, sometimes it's really important to be able to like jump navigate from screen to screen so that you can just so that you can get enough content onto the system. Cool, so that works. So the last thing I have in here that's programmed, I'm going to turn that off because it's annoying me. So the last thing I have programmed in here is this motor RPM counter. And so, oh, I gotta tell it to run. There we go. Okay, so I wrote a bunch of code in the PLC for setting this, but as you can see, this is displaying a dynamic value. So it basically it's taking that math that we did last time, and that math is being that math is being written into a data register, and then I just created a tag in the PLC for that value, and then created another tag in the HMI that's associated with this block that's just looking at that PLC data point and displaying it. So that way your operator has a nice visual cue of how fast the motor's spinning. So if you look at this code I wrote, I basically just did a really clumsy way of adding a plus or minus 5 RPM filter on this. Because if you remember from last time, this value was jumping around really fast, like it was constantly changing. So what I did here is I just, at the expense of 2 points in memory, I took the currently calculated RPM and I add and subtract 5 and write that value into 2 different blocks of code. And then on the next line, I just do a Boolean comparison of the current value against those calculated values. And if it's greater than or less than those specific values, then we write it to the screen, right? And so what this does is basically create a buffer to make sure like it's significant enough of a difference that it's actually worth writing it to the screen, because otherwise this is like bouncing around so fast all the time that you can't actually read it because it just keeps changing so fast, but it's only changing by a little bit. So that was a very long-winded explanation of what's going on with that. So that is almost everything I actually wanted to talk about this quarter, as far as the control stuff goes. You guys now have at least been exposed to programmatically almost all the most complicated stuff we're gonna talk about. That being said, there's one more topic that I do want to talk about this quarter, and that's PID control. And so those of you that are seniors, you've taken what is it, process control? What was that class called? What was 157 called? Anybody remember?
Process control.
Process control.
Process
Okay,
dynamics.
cool. I got it right. Yeah, I don't remember. Process something. But it's basically complicated math for how you get something like this motor, how you use the controller to get this motor to spin at the exact speed you want, right? And so the whole point of creating this RPM counter is actually to work towards using a PID controller. And so what we're going to do is we're going to take this input RPM value that we're physically measuring, and we're going to use that to actually tune and change our output continuously until we get the motor actually spinning at the exact RPM we want. So, because you remember, this motor is rated for, I'm gonna change the speed to 100%. So you remember we talked about last time, this motor is actually rated for 1725 RPM at max speed, right? But what we're seeing, bear with me here. What we're seeing is that it's actually spinning faster than that, assuming that our measurement device works correctly, which I'm pretty sure it is. And so if we had a process where we needed this motor to be at a very specific speed, this would be a problem, right? But we now have the tools to go and configure a PID loop. Don't get it confused with P and ID, which is piping and instrumentation diagram. PID stands for parameter in a proportional integral derivative controller, which is basically just talking about the math that it uses. But we now have all the tools we need to go program a PID loop and control this motor to the exact speed that we want. And so I've asked Dr. Ellis to give a presentation on PID. He said he's down, but he said it's probably going to be like 2 weeks before he actually has the time to do it. So I'll announce when we're actually going to do that. But where I'm going with this is I'm going to try to basically explain the key aspects that you need to actually program this loop. And then as we're working through that, at some point, he's going to give a lecture that's basically going to be a condensed, quick overview of some key points from 157 about why we're programming it the way we're programming it. So that's what you're looking forward to in the future. Now, for the rest of this quarter, I want you guys to program super cool stuff on the HMI and super cool stuff on the PLC and make those things talk to each other. So if you saw, I created a homework for doing series lights on a series timer. I'm going to come up with a few more project ideas like that. And then I'm just going to create 2 open-ended assignments that are, do something cool on the HMI and do something else cool on the PLC. And I want you guys to come up with or pick whatever projects you want to do and make those. So any questions about what we covered today? I'm going to turn this off. It's a little bit scary.
I got a question. It's
Yes,
not
sir.
about today's. I was wondering the homework on the last week.
Okay.
I didn't get to it. Is there a way to still submit the homework, or is it?
Yeah.
Okay.
Yeah, I know senior design got in the way. So which one was that, number 4?
Yeah, not the optional one, the other one, the motor calculator, the speed calculator.
Speed
I think.
calculator?
Yeah.
Yeah, so that's actually still available until the 16th. What I've been trying to do is actually extend the deadlines for this stuff, so that so that if life gets in the way, you still got time. So if the 16th isn't enough time, just shoot me an email and I'll push it out a little bit more.
Thank you.
Yeah. Anybody else? Did anybody try and have issues with installing the HMI programming software? That's good. That probably means nobody did it. Did anybody install it?
Yeah, I installed it.
I did.
I've installed
I
it.
installed it like just now.
It's just in demo mode.
Same here. Demo mode.
Yeah, unfortunately. So the next version release of this software, it's going to be free. But right now licenses are like $100. So hit me up and we'll hot seat that license, because they gave us 1 key. So that is available.
1 key, just 1 person.
Well, the thing is, it doesn't authenticate against a server. So what they asked me to do is just make sure that we don't use redundant copies at once. So what we'll do is just set up a remote session. So I'll email out with details of that. But anyway, I'm gonna stop.